Okay, sum to infinity. Let's just recap. One sum, and then get into the details behind it. What does sum to infinity do? You're actually telling me that because this thing is going smaller, all the time smaller, so my r has to be something that you divide by, so r is a fraction. If that is the case, you can get the sum to infinity, but that is a requirement. You've got to know that r has to be between 1 and negative 1. In other words, a fraction. And also r can't be 0. That's a given. That's a, let's say, restriction. R can't be 0. Because if r was 0, what does the sum look like? If I time with 0, and then I've got a problem, because if the next one is 0 and I divide the previous one, I'm going to get to infinite, to undefined. Are you with me here? Okay, so obviously r can't be 0. But it has to be a fraction between 1 and minus 1. Then this sequence will be what we are calling r is between negative 1 and positive 1. We call it a English
convergence.
So it converges. It gets so ridiculously small that what we are adding eventually
Will add up to
is
1.
insignificant. So that you can get to an actual answer for adding all of those very small together and actually get to an answer. Now there is a word for when it grows bigger and bigger, and that word is diverging. Now those of you who have science, converge means grows into something, and diverge means it goes out and gets bigger. You don't have to know that word. All you need to know for these sequences and series, it's got to get smaller. It converges into insignificance. When we are talking about converging, so they don't always say that word, but when they say that word, you must know that word and this goes hand in hand. Has to be an r that goes between 1 and negative 1. Then it will converge, and then you can get sum to infinity. If this was the other way around, if your series started here and then went that way, times 3, you can't do sum to infinity because it's getting bigger and bigger. It is diverging. You cannot get sum to infinity. So I can't ask that. Has to be diverging. Oh, sorry, converging. I'm saying the wrong word. So let's have a look at another sum. If this was, and these sums would be like two marks each for that, just for the sum to infinity, which is on your information sheet. Did you find it on your information sheet? Sum to infinity. Question here is, find the sum to infinity. Well, they don't have to even say find the sum to infinity. They can just say find the sum. You have to realize, look at this thing. It's a equal to 54, and it is r equal to what? Please check. 18 divided by 54 is? 16 divided by 18 is? Did I write it down correctly? Oh, 6, I'm sorry. I'm sorry. I took the easier way. If it was 16 over 18, it would have been 8 over 9, which I could do without my calculator, but it's wrong. Okay? It is and you would have picked up on the wrongness if you had said 18 divided by that, which is a third, and that isn't. There's a mistake. I wrote it down wrong. Please always check on the logic of it. Maybe you'll then pick up on something you did wrong. So the moment I see this and they say find that, what have I got to find? The sum. So the sum of what? It's going to be sum to, because it's going on and on and on and on, and it is converging. So therefore I'm going to do sum to infinity, which is a formula that you're going to know from now on. A is 54, R is a third. And you're getting an answer, an actual physical answer of 81, thank you. Right, meaning, you can already see that this is 2478. The next one will be if I time with a third. Okay, 30. The next one will be if I time with a third, 2/3. Are you with me? Can you see how they approximately got there? Remember that this gets so very small that it's actually tending to be nothing. So it's getting to be a fraction of 1 over millions and millions and millions and millions and millions, which is insignificantly small. It's actually tending to be 0. And that's the sum. Just to make it a little bit more interesting, can you find me the sum of this? Now first of all, look at it. Negative, positive. Negative should be positive, and I'm asking you find this. So I'm asking you find the sum to infinity. That you can only do sum to infinity if r is between -1 and 1. Is it? First of all, what is a? I'm so sorry, but there's a x. Can't do anything about that. Your r value though is you are dividing by 5, you're quite correct. But what would it be? It has to be over 5, it has to be negative because minus, plus, minus, plus. The only way that I can have 1 plus, minus, plus, minus, plus is by timing with a negative. So it has to be. So we double check. Go do it on your calculator. 3x over 5 divided by -3x. Let's do it old school. Times by 1 over -3x. Are you seeing this? That it's -1 over 5? Alright? And double check yourself with the third one over the second one as well. Now I know that it's sum to infinity, which is a over 1 minus r. A being -3x over 1 minus a fifth. Which will give me an answer in x. I'm sorry. There's no other way. Your answer will have some x in it, and then so be it. It doesn't always have to be a whole number like 81 or 13 and a half. What will this answer then be? Okay, I'm having 5 over 2x, I think. So we've got -3x. What am I doing now? Unfortunately, no calculator. Going to do this for you, but you're going to have -3x times with 5 over 6. 6 goes into 3 2 times, so it's going to be -10. Am I right? Did I do it wrong? Just help me here. So this is plus 1 over 5. 1 plus 1 over 5 is 6 over 5. Times with 5 over 6. 6 goes in there. I'm doing it wrong. I'm doing it wrong. 3 goes into 6. I said the other way around. 3 goes into 6 2 times. So we've got -5 over. But what about the x? It has to be there. Where? Just next to it is fine. At the top is fine. Doesn't matter. But also if it's next to it, don't put it down below by the 2. That's not right. So it's a little bit more difficult. But the formula is what it's all about. And it can only work if this is a converging series. I can only get sum to infinity if it converges. It gets smaller, 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 insignificantly small. Okay, the sum says a ball is dropped from a height of 100 meters. What's going on here? Can't they just give me this stuff? A ball is dropped from a height of 100 meters. And it loses 50% of its previous height every time. I don't know how they measured it, but okay, this is the sum. So you take the ball, you drop it from 100 meters. When it comes back, it loses half of its height. So now it's going to be 30 meters above the ground. And then, every time it bounces, it loses half. Determine the distance that the ball travels before coming to an end. Infinity. Okay, it's definitely infinity. That's why we're doing it, right? But let's think about this. So the ball is dropping 100 meters. Then coming back up 50 and going back down 50. So how far has the ball traveled so far? 2 200, are you with me? 100, 50, 50, then 25, 25. Are you getting this picture? And it'll go boom, 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 stop. Okay, in theory. In practical, I'm a little bit worried, but okay, let's say that is the sum. So what do I need to go and add together? All of these heights. Are you with me? So tell me the series. 100. Okay, that's fine. 100 plus 50 plus another 50. But then it's not a arithmetic sequence. Let's make it an arithmetic sequence. Are you getting my drift here? Well, where's the others? So we want to make this sum work, that I actually have a correct A and a correct R being half. 50% of is half is the ratio, right? And now I'm going to do sum to infinity. True? Okay. So sum to infinity then would be A being 100 over 1 minus a half, and that gives me so I'm saying 200 meters. What's wrong with this sum? We didn't count the up bounces. This was only downwards. So we've got to double it with a little bit of a twitch, but not the 100. Are you with me? This is downwards, but upwards there wasn't 100. So upwards, the sum of infinity would have been 100. But you see the twitches and turns that you've got to think of in this higher level type of a sum. So this is just downwards, if you want to explain to the marker. So therefore, upwards, the sum to infinity was 100 meters. But you've got to understand why. Because dropping it, it only went down once. Boom, 100. Then up 50, down 50. Up 25, down 25. So if I say this is sum to infinity and double it, I'm putting another 100 here that shouldn't be there. It only went down. It didn't go up. Little bit of a twitch. All right. So that means that the sum of the total distance traveled by the ball is, if you want to say 200 plus 100, or just say 300, that would be fine. It's very difficult. It's interpretation, right? Will all of the sums look like this and be in word problems? Definitely not, but I'll have to show you some of them as well. All right, sum to infinity.